In the Colour Space and Colour Depth course, we introduced you to the chromaticity chart and how standard definition, high definition and ultra high definition use different colour spaces. This course will make things practical by looking at how SDVoE deals with RGB, YUV and HDR. And we'll use terms which are introduced to you previously, so you may want to check back to earlier courses to remind yourself. Let's begin with identifying when each of these colour models are often used. The RGB colour model is widely used in the world of computing. And YUV is the colour space used for making movies and TV shows. It's YUV you would most typically get from your cable top box or media player. Now, while these two colour spaces are similar, there are colours which exist in one space and not the other. But to yours and my eyes, we wouldn't really notice any change after one had been converted to another. Unless you're a professional colour grader working on a high-budget movie, of course. However, if that conversion isn't done properly, it's really noticeable. Although RGB is associated with computers and YUV with consumer sources, there is no hard and fast rule about which colour space will be output by a particular source. When a display is connected to a source, EDID is used to determine which signal the source needs to send based on the capabilities of the display. If you want to learn more about EDID, check out our courses here on the Academy. In an environment where multiple sources and displays are used, you might encounter a mix of RGB and YUV signals, plus a mix of display capabilities. SDVoE endpoints can cross-convert between these colour spaces to ensure that a proper signal is delivered to each display. Think of this the same way you think about using scaling to ensure the original image will look good on each size and format of the display you use. So, why do we need to change colour space at all? The first reason is pretty straightforward. Flexibility. Some monitors only support one colour space and not others. For example, the DVI connection method doesn't support YUV. It only supports RGB. So, if a YUV signal is transported, it needs to be converted for DVI monitors to be able to display the image correctly. Let's face it, you probably aren't installing any new DVI monitors anymore today. A more modern colour space compatibility issue is brought about by HDR. What happens when you have an HDR source but a display which can't handle that HDR signal? An easy option will be to turn off HDR at the source. This will ensure compatibility, but it takes away the experience which was intended in the first place. SDVoE allows you to set the source to its highest output and transmit that signal to the displays while making sure each receiver can tailor the image to suit that display. Normally, if you tried to send HDR content to an SDR TV or standard dynamic range TV, you wouldn't see anything. With SDVoE delivering the signal, you will see an image on all your displays. Of course, your SDR displays won't show HDR image quality, but the picture will be viewable. For example, people may want to continue watching a movie whilst they head to the restroom. And while they're in there, they won't be complaining about the image quality, but at least they won't be missing anything. The second reason colour space needs to be converted is to allow SDVoE applications like fast switching and multiview to take place. In order for SDVoE to seamlessly switch between content, all the signal parameters have to be constant. Remember, the trick to fast switching is never to let the TV know that anything is happening. If the TV detects a change, it would need to resync, which will take a few seconds of black screen. Meanwhile, if you were to change colour space without telling the TV, you would end up with the pink and green hued mess that is the signature of a misinterpreted colour space. Multiview is all about sending multiple images from separate sources and compiling those signals into one display. Since it isn't possible to send an image that is partly YUV, partly RGB and partly HDR, all signals must be converted to a common colour space in order for multiview to function and show a clear image of all sources. The good news for system designers and programmers is that this whole conversion process is automatic. SDVoE makes intelligent decisions without any setting ever being applied. However, for the most complex scenarios or situations with highly discriminating users, SDVoE is already being deployed in the environments of major Hollywood studios, for instance. The API gives you full control over colour space management at every point in the signal chain. And this reinforces the power of SDVoE for everyone, regardless of skill.